Maybe. It's cool out. Okay. So, greatest common factor. In your own words, what would a greatest common factor be? How would you define it? So it's the biggest number they all have in common. All right? So, we're going to do two kinds of factoring. We're going to do greatest common factor, and then we're going to do sum and difference of squares. All right. So first of all, 12 and 24. What's the greatest common factor? Why isn't it 24? Because inevitably you're going to say 24. Right. 24 is too big. It doesn't fit in the 12, right? So the greatest common factor here is 12. So the same thing applies to this. Where did it go? The same thing applies to this. If I wanted to know what's the greatest common factor here, the 6, the 4, and the 3, they don't have anything but a 1, right? But what about the exponents? I have 6, I have 5, and I have 3. So what is the greatest common factor with your x's? 3, right? This has 3, this has 3, and this has 3. So the greatest common factor is x to the whoa. I don't even know what just happened. All right. So the same way between 12 and 24. You said 12 is the smallest number for both of them, right? The same thing applies to the exponents. What's your smallest exponent? 3. And so that's your greatest common factor for the exponents. All right? So, if I look at 5x squared and 5, first of all, between 5 and 5, they both can be divided by 5. And so I have an exponent of 2 here and an exponent of 1. So my smallest exponent is 1. So I'm going to divide by 5x. And when I divide by 5x, I'm going to put the 5x on the outside, and then I go ahead and divide. So 5 divided by 5 is 1. X to the second divided by x. So if I have 2 x's, 1 cancel out and leave me with 1x. So I have x minus 5 divided by 5 is 1. And what happens with my x's? They cancel out. So this is what we get. And this is called dividing out a greatest common factor. So 14, 28, 21. What number can we divide? 7. Because 14 doesn't go into 21. I think I heard someone say 14, but 21 can't divide by. Now, do they all have an A? The 21 doesn't have an A, so you can't divide by an A because there's no A's here. So you put 7 on the outside. 14 divided by 7 is 2. 28 divided by 7 is 4. And 21 divided by 7 is 3. Six, 3, 24. 3. And then x to the third, x to the second, and x to the first. So I'm going to divide by x, and that goes on the outside of the parentheses. 6 divided by 3 is 2. 3 minus 1 leaves me with 2. The 3's cancel out. 2 minus 1 is 1. And the x's cancel out, and I'm left with 8. Okie dokie? All right. So on number 5, I have negative 15, negative 20, and positive 25. So first of all, if your first term is negative, we're going to divide by a negative, no matter what. So all of these are getting divided by a negative. So 15, 20, and 25 is 5. What's your lowest exponent on your m's? 2, and your lowest exponent on your n? So you're going to divide all of them by that. That goes on the outside of the parenthesis. Negative 15 divided by negative 5 is 3. 3 minus 2 is 1. 2 minus 1 leaves me with 1. Negative 20 divided by negative 5 plus 4. The m's cancel. The n's cancel. And then 25 divided by negative 5. 5 minus 2 leaves me with 3. And 5 minus 1 leaves me with 4. So how about the next one? What do you think I'm going to divide by? 7, 5, and 2. What do they have in common? 1, and it's a leading negative, so they're all getting divided by negative. Is there an x in all of them? Yes. So I'm going to do a negative x all the way across. So negative 7 divided by negative 1 leaves me positive 7x squared. 5x squared divided by negative x leaves me with and then plus 2. All right, go ahead and fill in the chart. What's 14 times 14?
196.
196. I knew it ended in 6. And what's 16 times 16? 256. There we go. And 11 times 11 is 121? Okay. Okay, so the reason we're filling in the chart is because we're going to factor perfect squares. And these are all perfect squares. So we're going to use this number, and so the square root of 121 is 11. The square root of 144 is 12. So here's how this is going to work. First of all, it has to be a minus between it. So this has a minus. And that's the only time it works. If it's a plus, it doesn't work. It has to be a minus. The second thing is, it has to be a perfect square. So is 16 a perfect square? Yes. So this is how it works. What's the square root of x squared? X. And what's the square root of 16? 4. And we're going to put a plus and a minus. And here's why this works. From yesterday when we multiplied, what's x times x? And then x times the negative 4 gives me minus 4x. And the plus 4 times the x gives me plus 4x. And then 4 times the negative 4 gives me minus 16. So what happens to my middle terms? They cancel out and leaves me x squared minus 16. And that's the only time it works. You have to have a plus and a minus to make the middle term cancel out, and you take the square root of the first and the last. And it has to have a minus in between it. So x squared minus 4. Is there a minus between it? Yes. So the square root of x squared is x. The square root of 4 is 2, and you put a plus and a minus between it. On the next one, is there a greatest common factor? 4. So if I divide out the 4, I get x squared minus 9. And so now, is 9 a perfect square? It is. But don't leave out the greatest common factor. He's going to get his feelings all hurt, okay? He wants to be in the answer too. So we're going to have 4, and then we're going to have x plus 3 and x minus 3. You have to keep the greatest common factor or you get it wrong. Can I do the next one? Why? There's a plus sign there. It has to be minus, so this is prime. 25 and 81, is there any greatest common factor? Are they perfect squares? They are. What's the square root of 25x squared? 5x and 5x. And the square root of 81? 9 and 9 and 1 plus and 1 minus. It's kind of fun, isn't it? Admit it, you're having fun. Is there a greatest common factor on the last one? So if I take out a 2, is 3 a perfect square? So I can't factor it.